Okay, next I'm going to draw in the LCD and get its panel cut. It's pretty simple, so I can do this all at once without, creating the rest of the unit. So we have the LCD glass here, and then there's the driver portion that sticks out the bottom. It probably sticks out the bottom, so it doesn't have to be on the back, which makes the entire LCD thinner, but it makes it wider. We also have to draw in where the data cable is right here, and we want to give it a wide berth so it doesn't bend itself too much because it's a thin connection, it's fragile, we don't want it to break. So once we know the size of the LCD, we can do a 0.075 offset from it right here, and that is what we'll use the funky foam for. And so apparently I'm addicted to funky foam. So it's really great for things like this, and this is what I actually use it for the most. Funky foam is this adhesive-backed foam, and it's very consistent. It's 0.075 inches thick, always, which means you can count on it. So if we were to make a concavity in a stiff material for this LCD and just have, very little tolerance or no tolerance, you could probably cram the LCD in there, but, it's a thin piece of glass, and the edges are the most susceptible to damage, so that you don't want to do that. But with funky foam, you can say, okay, here's the size of our LCD. We come the distance of the funky foam, then we design the rest of the shape around that. And the thing that's great about funky foam is it's foam, but it has some compression to it. So if your measurements aren't quite exactly right, you can still press the LCD between the funky foam safely and also have it fit firmly. So in a way, the funky foam almost acts like a spring, keeping it all centered. So the LCD itself was very thin. Let's see, how thin was it? Less than 1/8 of an inch. So kind of like a car's windshield, the LCD being glass actually has a decent amount of strength, but since we're not putting aluminum around it like a MacBook, we need to actually shore it up a little bit. So what I'm going to do for this is have a front portion, which will be 6 millimeters thick. We'll cut that out of Sintra and create a concavity in it for the screen. Then we'll cap it off with a piece of 1/8 inch thick black acrylic, which will give it more rigidity. We'll bolt them together, and then we can actually use the black acrylic to our advantage. We can laser cut it and have a backlit logo on the Novena laptop itself. Because usually with these LCDs, it didn't used to be like this, but now it is. There used to be like a metal backing on the back of them, which would help reflect the light, but apparently the light refraction is better now, so some of the light spills out the back, and that's actually how they light up the logos on the back of laptops, because that light's already there. So before I can actually route the LCD portion, I need to make the hinges. I'm going to have to do these custom because, as I said, this material is pretty thin. So 1/2 of the hinge will connect to the top of the unit, which is not that thick. And then the other half will connect to the base of the Novena. So I kind of drew the hinge here. Even though this is the front view, I drew the hinge on the side just so I could see the thicknesses. So this larger rectangle represents what will fit into the base. The circle is the pivot point, and this rectangle at the top is actually what will slot into the LCD side. So I'm going to go to Fusion 360 here. Here's that same thing drawn as a sketch in Fusion 360. And what I'll do is I'll extrude this out into pieces, into 2 pieces. So I want to make sure I extrude them separately as separate bodies. And that will actually give us our top and then our bottom. And there's screw holes here as well so that it can attach to the Sintra. So the screw pattern here, I have to make sure it matches the 2-dimensional pieces I've drawn down here. At this point, you might ask, why didn't I draw this entire project in Fusion 360? It's because I'm not versed well enough in 360 to actually do this. So it's faster for me to get this project done using a mixture of Fusion and Adobe Illustrator. Because Adobe Illustrator is really good for routing, which Fusion can also do, but again, when you have a schedule, you do what you know rather than what you want to learn. Okay, so I can 3D print this hinge out, and then we'll attach the hinges to the LCD portion, and then once we assemble the whole unit, we'll bolt the LCD via the hinges to the base. Now I'm going to use the size of the keyboard mount and the size of the LCD to determine the overall size of the main unit. Since the Novena board itself isn't that large, we can basically put it wherever it fits best. So we're going to keep it centered on the keyboard And then we're going to put the two other largest components, which are the SSD and the battery, on either side of it. There's also going to be a fan that we pulled out of an old server or something in the unit to keep the system on a chip cool. So this fan will actually blow up in this direction. The charger board also gets pretty warm, but from the documentation, it's the SoC, system on a chip, that we actually need to keep cool, at least if the unit's enclosed, which it could be if the keyboard's in place. Okay, so on the left here, we have the battery, which I think is actually thicker than the PCB itself. Got it drawn here in the side view. And the thing that I had to keep in mind was that the battery couldn't intersect with the keyboard mounts, and these are the pieces that actually hold the magnets that connect to the keyboard. They look like this. Yeah, so I tried to make these as small as I could, but I could only get them so small. See, the magnet fits up in there. So therefore, this kind of limits, one doesn't limit the size of the case, but I had to actually make the case a little bit bigger because the magnetic keyboard mount has to fit under something so it can screw into it, and then the keyboard sits on top of that, so everything's related. There's also a base plate. Where is that here? It's on one of these layers, unless it isn't. Oh, there it is. So the battery fits between the aluminum base plate and the plastic keyboard magnet mount. Over on the right, we have the SATA drive. It will fit just under the FPGA breakout board, which isn't pictured here. And then if we have this up enough, which it should be here, we should have just enough room to loop over a solid SATA cable without having to cut down the SATA cable, which I don't want to do if I don't have to. Because if you hack up a SATA cable too much, you'll affect the data transfer rates and it basically won't work. And down here at the bottom, we have the fan, which should fit just above our little component box that we made in a previous episode. The component box has a mount that actually makes it bolt to the base. That's actually right here, and the fan's just above it. We had to make sure the fan matches the hole that we cut in the base of the unit. That's one of the reasons why I'm going to put rubber feet on the bottom of this. So the base of the unit is raised up enough that airflow can get underneath it. So air is sucked in through this hole and then blown onto the Novena. The first things I'm going to route out on the CNC machine are what I'm going to call the top risers. This is the portion that holds the power button here above the keyboard, and the portion below the keyboard that will have an opening for our component box as well as contain the speakers. And I'm thinking the speaker riser can actually detach via magnets. So if you want to move it to get at the component box or just do some more hacking, you'll be able to. I start separating out the pieces on my design as I'm going to route them. So these are layers 4 and 3, so I actually separate them and label them just to make sure I've got everything the way I need it, and then I'll take these two-dimensional images and put them into my program to turn them into toolpaths for the CNC machine. I'm going to start by routing the top and bottom risers, which are 2 layers each, as depicted here. Once I have those things built, that'll give me an idea of what the rest of the case is going to look like. So instead of making everything at once, I make it one piece at a time, just in case it's a problem. So the lower riser is a bit more complex. There's a big concavity here for the component box, and there's countersunk portions for the magnets, so it will magnetize in place. There's also speakers here, so I have to enclose the speakers so there's a gap on top, but then they're enclosed on the bottom. Then I have to route a channel for the wires to go from one speaker to the other, then cut a big hole through the bottom so the wires can come out of the bottom of the unit, and then finally when both halves of this are put together, it's basically sealed. And there'll be an acrylic top to make it look cool. So once I wire it up, it's basically sealed forever, since I'm going to once again screw and glue it just to make sure it's stuck. So the wires that I add, I'll make sure they're way longer than they might possibly need to be, so I can just cut them down in the future instead of having to lengthen them. That's why I always add more wire than less, because it's much easier to cut a wire than it is to extend it. And then I guess it's wasteful, but your time is actually worth more than the wires. Sorry, environment, I can't back you up on that one. Okay, with the risers done, I'm going to start on layer 3, which is the keyboard mount layer. You see these 4 pieces here, and that's actually where the 3D printed keyboard magnet risers attach to. as I randomly give names to things I did not have names for before. It's like I'm writing a Dr. Seuss novel. The Scarafaragan went into the Babbleduke forest and found a Balazahoot. This portion here represents the battery, and again, as I mentioned, the battery is pretty thick, so I'm going to route an extra concavity on this layer so the battery has enough room to fit. And these spots here represent the magnets that mate up with the magnets on the speaker portion. And of course, there's a big hole here for our 3D printed component box. All right, I'll get this put together and then make sure it fits the keyboard.